In note 6.4, part 3, example 4, we're going to graph reflections of sine and cosine functions. The first graph that we're going to make is f of x is negative sine x. When we have a negative outside the function, the corresponding transformation is a reflection in the x-axis. This is because that negative 1 on the outside multiplies y values by negative 1. We're going to begin by graphing the parent function, which is y equals sine x. Remember, the graph of sine starts at the origin, so 0, 0, and there are key points every quarter period, which is every pi over 2. So it's going to start at the midline, and then it's going to be increasing to the maximum a quarter period later. So the graph is going to go through pi over 2, 1. You'll also have to put a scale on the y-axis like I did. Next quarter period will be back at the midline, so pi 0. Then 3 pi over 2, negative 1. 2 pi back to the midline, 0. 5 pi over 2, 1. 3 pi, 0. And in the negative direction, negative pi over 2, negative 1, and then negative pi, 0. I will sketch in the parent function using a dashed line. So this is y is equal to sine x. And now we need to graph the transform function. So for the transform function, it's a reflection in the x-axis. So we're going to multiply all the y values by negative 1. So 0, 0, 0 times negative 1 is still 0. But when I'm at pi over 2, 1, we multiply the y coordinate by negative 1. So 1 times negative 1 will be negative 1. Or this may be easier just to reflect all the points rather than thinking of multiplying by negative 1. So I'm going to reflect the point negative pi over 2, negative 1 to negative pi over 2, 1. And all the points that are on the midline at y equals 0 stay there. So the red graph that I'm drawing is y equals negative sine of x. All right, let's do the analysis. So the domain of y equals negative sine x is all real numbers, negative infinity to infinity. The range are all y values. So the range is going from negative 1 to positive 1. So the range is negative 1 to 1. We haven't changed that with just a reflection over the x-axis. The period is always, for any function, sine or cosine, 2 pi over b. In this case, b is 1. We're going to take just positive 1. So 2 pi over 1 is 2 pi. We have not changed the period of this function. The amplitude, remember, is the distance from the midline to the maximum, or the midline, the maximum, sorry, I should go to the red function, midline to the maximum, or the midline to the minimum, which is 1 unit. So the amplitude is 1. That has not been changed by the reflection. The transformation we already did. We're going to go over to number 4b, and we're going to graph f of x equals cosine of negative x. So the transformation is caused by this multiplication of x by negative 1. So when we multiply by negative 1 inside the function, that's going to affect x. So this transformation is a reflection in the y-axis, because we're multiplying x values by negative 1. So I'm going to begin by graphing the parent function. The parent is y equals cosine x. When graphing cosine, you're going to start at a maximum point. So cosine begins at 0, 1. And then there's a key point every quarter period, which for the parent function is every pi over 2. So we're going to be at pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi, 1, 5 pi over 2, 0, 3 pi, negative 1. And in the negative direction, negative pi over 2, 0, negative pi, negative 1. So I'm going to dash in the parent function. And make sure you put arrows on the ends and show that it's curving back up. in this case. So y equals cosine x, that's the parent function. And now we're going to graph y equals cosine negative x, which means we're going to reflect each point over the y-axis. So 0, 1 stays at 0, 1. Pi over 2, 0 is going to be reflected. So if I take pi over 2, 0, it's going to be reflected over to negative pi over 2, 0. So we'll plot that point. If we have the point pi negative 1, we're going to reflect that over the y-axis. That's going to be pi negative 1. And once we have those points, we know the pattern for a cosine function, that it's going to go from a maximum to the midline, from the midline to the minimum, minimum to midline, etc., every quarter period. So I'm going to go ahead and plot the rest of the points. And what we can see happening here is the graphs are actually the same. So reflection over the y-axis does not affect the graph of cosine. So this is the same graph as y equals cosine x. This is the graph of y equals cosine negative x. And we should have known this already because cosine is an even function, which means it's symmetric over the y-axis. So reflection over the y-axis is going to result in the same graph. In terms of the characteristics, the domain is negative infinity to infinity. The range is negative 1 to 1. Those are all y values. We did not change the period with just a reflection over the y-axis, so the period is still 2 pi. We did not change the amplitude with solely a reflection over the y-axis, so the amplitude is still 1.